So previously, I kind of dissed bismuth a lot. And I want to now say why I think bismuth might have use in the future. When you're trying to do a lot of welding or 3D printing constructions, you want supports so the thing doesn't collapse. But also with welding, there's welding techniques that require you to put a lot of pressure on something to fuse them together. And so instead of heating them up as much, you press them, or you generate a lot of friction or shock wave, and then it fuses together. And this can be better than heating up the material, because when you heat up and cool down the material, you cause it to expand and contract, which can form cracks. It can alter the crystal structure in sometimes very negative ways. But when you press it together, it can preserve it and actually make the material much stronger. Now, if you have two supports like end, and then you use those to press two plates together, then you get rid of the supports, you can do it. So you can imagine that being like I would just draw, and I don't know how to draw backward, a T where you have the supports, and from the supports is where I put the pressure on these two plates. Or better yet, an 8. And I use these outer supports just to put pressure in between the two things. Now, now you want to remove the supports afterwards. I think bismuth will be ideal material for this for metals. Why? It melts at 271.4 degrees Celsius, which is not that hot at all. But you want something that melts not as much as like a plastic or organic material, like cornstarch, which you can use for other ones, because those materials can catch on fire, be corrosive more, and organic materials tend to decay at a lower temperature, so even if they have a lot of other things. Bismuth not, and bismuth, you can easily increase the temperature it melts to make it even more compatible with the system, so it doesn't melt too early, by mixing it in with other metals to make an alloy. And this alloy could have lots of wonderful things, but bismuth alloys are not widely explored. So that's the first one. It is also one of the heaviest elements, which means that you can have it very, very stable, and easily, once it melts, you can just drip it off with gravity and stuff, or shake it off. It's not going to disturb and flow around. It's much more predictable, and you can use it to weigh stuff in place. It has a very low thermal conductivity and expansion, which means it acts very big. You don't have to worry about it expanding and contracting in weird ways that might mess up your welds or prints or whatever you're doing. It has a low thermal conductivity, which is important because it's not going to conduct heat from one part of the material where you're doing welding or 3D printing to another part and mess up your whole thing. Now, it's one of the lowest thermal conductivity for metals. It's still a metal, so it's still high compared to a lot of other things. Now, the nice thing with both of these properties is an alloy, again, can have it even more extreme than it. And compared to other traditional alloys that have these properties, include lead or arsenic and stuff, a lot more toxic ones. So this low thermal, so it has a lot of ones, and generally metal alloys, even adding a little bit of another metal, really lowers the thermal conductivity, because metals have like a little atoms floating in the sea with a very nice structure. Heat flows through metal kind of like a wave or something, with a whole lattice and all the materials moving at once in a nice pattern, unlike a lot of other things. If you put a little bit of anything else, the sea is disrupted. If something's bigger, it pushes away electrons more, and stuff deforms around it. So even a little bit of any other material, less than 1%, can reduce sometimes thermal conductivity by over 10 to 20%. So it's not that hard to think they could reduce it even more. And sometimes they can reduce the expansion by giving it more partial conformations and not just it getting bigger. Low reactivity. Bismuth doesn't react strongly at all to a lot of things, and it doesn't really catch on fire like a lot of other ones, like aluminum or sodium and stuff. They also have a kind of a low melting point. So it's one of the safer ones. It's safer than even iron with reactivity. So, it's just safe. It's very non-toxic. used in Pepto-Bismol and a lot of medications. And it's one of the few things that melt at a low temperature, and that's heavy, that's non-toxic. Most heavy metals are very toxic. Arsenic being the most famous example, but there's a lot of other ones. Lead. And it's now relatively cheap. Now if we start mass using it, it might get more expensive. But I still think it'll stay cheap, and the reason why I think it'll stay cheap compared to everything else is because you can find it in many different ores around the world, but it's not well used, and it's more seen as a waste product. And we use so little of it. We only use a couple hundred tons of it. I think it was 100 tons in the U.S. annually, and it's the process thing are recyclable. You can recycle it and use it as support for other things. You just melt it away. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. With your help, I think I can do it. Again, thank you very much. Goodbye.